is it? What are the forces acting? The weight will act, no? Due to weight, the block will accelerate down. So then anything will happen to spring. The spring starts getting elongated. So let this elongation in the spring be x1. The weight mg is acting. Spring force will act. It will accelerate and it will have, block will have velocity v1. This what? Not vertical. Or no. No. What is the type of motion you describe? What is the type of motion you describe? You have to go back to kinematics and laws of motion. Spring force will gradually increase, no? So therefore, shall we say like is it a retardation or acceleration? Decreasing acceleration but increasing speed. Because what is earlier mg? Now how much? Mg minus kx1. So net force on the block increases or decreases as the block descends, will decrease. Acceleration decreases but speed will be increasing. We'll get some mean position. Purchase one spring and make observation. Now I'm going to say that here it is going to have maximum speed and elongation x naught, this mg. So what is the elongation of the spring? Is x naught. Why this speed will be maximum? So again suddenly you brought Vm, because now net force on the block will be 0 and I am going to say it's the maximum speed. So the reason for that is very next moment. What do we see is like the spring force will be greater than the weight. So here we'll take this as kx2. You show retardation, this is the velocity v2. Now this is the elongation. Still it's elongation only. So what do you mean by elongation? When the length of the spring is more than its natural length. This is a natural length. So all this, everything is elongation only. Now finally what will happen? The block, what is the state of block, will undergo retardation and finally it will come to instantaneous rest. Okay, this will be the maximum elongation. Okay, this everything is called as a maximum elongation. So now what is the state of block? Instantaneous rest. Now after this, which force will be greater? I think here spring force was equal to weight. No,
Sir, your
is
voice is
greater than
breaking.
mg, so it will undergo retardation and finally come to rest. Now what is the spring force?
Sir, your voice is breaking.
Yes, sir.
Can you hear me? No?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, no. Let's continue. Okay, overall, some sequence is going on. So we'll call this as a mean position. So some words are there, very, very important for us. This dotted line, black line, this is called like a mean position. This is the upper extreme. Upper extreme, this also. I need a lot of space. Yeah. This is called like a lower extreme. So this position.
Sir, your voice.
Yeah, I'll make it no. I think you can hear me clearly now.
Yes, sir.
Yeah, fine.
Yes, sir.
I think lower extreme, upper extreme, like this, the conditions is what we have put it, and we'll call this a mean position. About mean position means about this, the block will oscillate to and from motion. What the state of block will be. Now the block is released from rest here. Now I'm interested, what is this kx naught? Are you looking at this one? Kx naught equal to mg. Okay, this mean position, what is the elongation of spring? Then this maximum elongation, how it is related to elongation at mean position. At lower extreme, it should come to instantaneous rest for a while. It will be at rest. Again, it will start accelerating up. So what is the motion of the block? It will be to and fro motion. See, here at lower extreme, what is the state of block? Should be at rest. Upper extreme should be at rest. See, you do one thing. Just take some elastic band, suspend some rock, small rock, release it. Then it will go like this down. For a while, it will be at rest. Then again, will move up. No, will be oscillating. When it is oscillating up and down, at upper extreme, lower extreme, what should be the state of the block? Should be at rest. This is very, very important. As students are asking, sir, at upper extreme, why it is at rest? Open eyes, take one elastic band, connect one rock, release it. You see it will be at rest at these positions. Instantaneous rest, not continuously, will not be there. Again, what happened to block? Again, it will move up and down. It's a to and fro motion. We are discussing one oscillation here. Now, at mean position, what should be the kx naught? Kx naught should be equal to mg. Now, what do you mean by mean? Equilibrium, net force should be 0. So kx naught equal to mg. I'm interested in this maximum elongation. Okay, I wanted to find this maximum elongation. So what is the xm? Xm I'm going to call it as maximum elongation of spring. So can we find out that? can I apply conservation of mechanical energy? Because what is mg? Conservative force. What about spring force? That's the conservative force. Both are conservative forces. Only conservative forces are doing work. Can we apply conservation of mechanical? The answer is yes. Then how to define gravity? I think gravity is by virtue of position. The gravity is what we define by virtue of position. So here, when the block moves from this first diagram to say this position, from the upper extreme to lower extreme, the gravity does positive work. Am I right? What about spring force? Spring force does negative work, and they're moving from rest to rest. You can apply conservation of mechanical energy, or you can apply work energy theorem. Here I'm more focusing on conservation of mechanical energy. How to bring that conservation of mechanical energy? So let me define this as the lowest point to measure the gravity. H equal to 0. Then let me apply the conservation of mechanical energy. U, I'll call this is 1, this is 2, this is 3, this is 4. Like this, we'll take some reference positions. I will take the hint one more, this one. 4, 5. Can we apply between 1 and 3? Yes, we'll apply the conservation of mechanical energy. So this will be U1 plus K1 equal to U3 plus K3. What about potential energy? Potential energy means both elastic potential energy and also spring potential energy. Here, this should be mg xm, because what is the gravitational potential of the block compared to this is h equals 0. mg into xm, this distance is xm. Are you looking at this? Plus elastic potential energy stored in the spring 0, kinetic energy 0. This everything is U1. Now come for this one. U3. Here, what is the gravitational potential energy? Will be 0. Elastic potential energy. What is the state of the block? It is at rest. Release from rest, intense rest here. So this was the thing. Okay, finally what do we got? mgxm equal to kxm square by 2. So what is xm is equal to? I got this is equal to 2m by k. Two mg by k. What is x naught? X naught equal to mg by k. So therefore that maximum elongation and the elongation at mean position, how much they are related? xm equal to 2 times of x naught, comparing these two. Okay, what about this length? Because what we got finally, because x naught equal to mg by k. Okay, so this root will not be there. One xm will get cancelled. No? Yeah. Xm equal to x naught we got it. So therefore, can we say anything about this distance? How much it will move from position 1 to position 2? Well, the same distance it will move from 2 to 3. Yes, it is, because xm equal to 2x naught. If this is x naught, then this should also be x naught. So therefore, I'm going to take this is x naught. So how much the block will move down below mean position? By x naught here. If x naught is elongation at mean position, how much of maximum elongation at lower extreme will be twice of elongation at the mean position? This is a very important thing which we are discussing. Can you equate kxm equal to mg? No, kxm is not equal to mg. Kx not equal to mg. So you should not equate forces at lower extreme. Are you getting? Very, very important. At mean position, net force is 0. Equilibrium. I think we have studied in laws of motion. When under action of force, if the system is at rest, it is said to be in equilibrium. So, but it's motion, whether at rest or in motion. Net force 0, it is said to be equilibrium. At mean position, you should equate forces, not at extreme point. At extreme point, what is the equation you are going to write? Kxm minus mg equal to a. So Kxm is greater than mg. So you should not equate forces where at extreme points. At mean position you should equate. Getting the idea? This is very important fundamental. How to calculate this Vm? Next question. How to calculate this Vm? Shall we apply between 1 and 2? As we'll apply conservation of mechanical between 1 and 2. U1 plus K1 equal to U2 plus K2. I'll show that one. So now I'm going to define this as the position 2 as h equals 0. So this will be mg x naught plus 0 plus kinetic energy is 0. What is U2? Potential energy is 0. Then elastic potential energy stored in the spring is kx naught. Let's see that what is Vm, we are going to get it. So this will be mg x naught. We know kx naught equal to mg, no? Already we have that one kx naught, so I am going to substitute mg x naught equal to k1 x naught kx naught is in fact mg. This will become mg x naught by 2. What is Vm? 2 will get cancelled. Vm will become equal to gx naught. So x naught equal to mg by k, if you want to write in terms of that. Okay, this is the maximum speed. Now you have to ask one very beautiful question like, sir, why I should do all this? Directly I know I am very good in kinematics and I am very good in laws of motion. So I'll find out that velocity. Try it. It will be very, very difficult. More time taking one. We are avoiding all that integration. So when the block moves from position 1 to 2, mg is a constant. What about spring force is a variable force? Then what we should do? What is the equation you should write? Mg minus kx equal to ma. You see that why your teacher is insisting is mg minus kx equal to ma. Then you should integrate, then you have to solve, you will get that speed. So to avoid all this, we are bringing conservation of mechanics. What is the advantage of conservation of mechanical energy? We can avoid mathematics, or we can say goodbye to mathematics. We need not to get involved in the mathematics. Straight away, with the help of simple algebraic equations, we can end up the result. I got the speed, you see. To get the same speed, you have to really put integration. There are some problems are there where with the help of integration we can never find out. Very difficult. So therefore, it's advisable to go for the conservation of mechanical energy only. This is a must, very useful for us. Anybody having doubt, you can. There's a minimum basic. Before going for numericals, no, we need all this background. Any doubt you can clarify. At extreme point, what is the state of the block? Horizontal or vertical spring block. At extreme point, the block will be at rest. Where in spring block system, where the block will have maximum speed at mean position. What do you mean by mean? Net force should be 0. Any doubts you are having? Okay, hoping everyone understood. I to discuss numerical after break I'll continue.